excited. Round two. Let's do this. All right. Welcome everyone to the new episode of Haptics Club podcast. I am Ashley from Titan Haptics. I'm joined by my trusty Haptics crew. We've got Eric and Sarah from Haptics, Manu from Unity, and Gus and Irina from SenseGlove. The Haptics Club is a team of people that have a passion for haptics. Our goal is to raise awareness of all the amazing tech and people and things happening in the haptic space and foster interesting discussions on the subject. We are so happy that we're here for season 2 of Haptics Club. We have got even more surprises, crazy guests. And speaking of crazy guests, this one is a life goal. Today we're joined by Vincent Hayward, the godfather of haptics, industry pioneer, co-founder of Electronica, so many things, super excited. As a heads up to the format, we've got an hour. We're going to talk here. We have questions about just an introduction to get to know Vincent. We're going to talk about the future of haptics, challenges, and of course we'll jump into things like area of expertise and all the things, all the juicy questions that people have sent us. So with that, everyone, for goodness sake, if you haven't by now, join us on Twitter at Haptics Club. We've got a newsletter so you can stay tuned to all these amazing podcasts, things that are going on. And we have a website, the Haptics Club, where you can check out everything that's going on. We've got a lot of crazy stuff happening this year, and we are blessed by guests like Vincent. But let's get started. No one wants to hear me talking for this long. They want to hear what's going on in Vincent's world. So Eric, let's kick this off.
Fantastic, Ashley. As usual, incredible introduction. So, Vincent, as you know, our podcast is divided in 3 different sections. So let's start a little bit with the introduction and get to know it a little bit more. So, Vincent, you're arguably really one of the most influential figures in haptics, right? With more than 30 years in the field. First at McGill and then back to Paris at Easier, and Electronica. So we also heard several listeners say that you were the reason they started in haptics. So how you, in the first place, got involved in haptics, and what made you say, I want to spend a lot of time and effort in this discipline?
Yeah, thanks for the question, Eric. Well, so it started with an anecdote. I remember it still. It's not a false memory; it's a true memory. It was a Christmas '91 when an evening, and I was talking to a fellow called Christoph Rammstein, who I think is no longer in that area. But basically, Christoph at this time was working at the equivalent of the Canadian CNRS, like the national labs. And he was working on accessibility, and he had invented a system for, you have to put in context, 91, essentially Microsoft came up with Windows. And before that time, everybody was using computers using line commands like Unix and DOS. And then all of a sudden, computers over the space of a few years became all graphical interfaces, and he was working on accessibility, and it was a huge problem because you had lots of jobs associated with line commands, because if you have a Braille line, refreshable, then you can program a computer, there is no problem. But if you have a graphic interface, you cannot. And so he was working on that problem, and he came up with an interface that was talking. So as you move the mouse around, then the icons were speaking, or they were making sounds that would evoke their nature. And then we were talking about this, and said, why not making a tactile interface that would be on top of the, if you want, speech and sound interface. And so I went ahead, and then basically, and we talked to a small company in Montreal, actually, Visuate at this time, which in the meantime has become really big. It's a big company. It's like one of the major, actually, in accessibility. And then Gilles Pépin, I remember, thought, oh, that was a great idea, and he gave us $2,000 to buy electric motors, and went to the space agency. I was working at the space agency, and said, oh, well, we'll do the machining for you. And then I got together with undergrads And in the space of a year, of 2 semesters, we had made this pantograph, which was our idea about how you would transform a graphical landscape into a tactile landscape. And so and after 2 years, essentially, it was working. There was quite a challenge. Actually, Christophe made the software, and it worked really well. And so that was the beginning. And say, we invested maybe $5,000, and we have this really interesting thing going on. So that's where the start.
That's awesome. You also managed to get paid for your first haptics project, so that's really
It was a donation, from the Canadian Space Agency, and then Gilles Pépin,
yeah. People right now pay for do haptics, so that's the starting point. So thanks for sharing this fun story. So you're also a co-founder of the Electronica startup, right? So how do you divide your time between research and teaching and entrepreneurship? So what's your week or month like?
Well, there are several theories about how to do that. Basically, I spend 2 days a week at the company, and then the rest of the time at the university or at home. These days, mostly at home, because I teach only 1 class, actually. And I no longer, I have grad students which actually are at the company, and then only 1 left at the university, who's actually in Delft, so it's a little...
They're spread out everywhere. That's cool. Thanks for sharing. And how does it feel as an experienced researcher then to contribute to a startups? Because startups are really fast moving. They are challenged, change all the time. They work under big economical constraints. So it's really different world from research in some way, where you have dilated time and you don't really have lots of let's say these constraints like business. So how does it feel like as an experienced researcher working in that space?
Oh, I think there's only one method. It's actually to work with someone else who has experience in business development. There is no way about it. And that's my fourth startup, actually, Electronica. The first one actually was with Christophe Ramstein in question, and then we had a serial entrepreneur called Matthew Mather, who became actually a sci-fi writer in the meantime.
Wow, that's amazing.
He's actually very successful. He's one of the bestseller, doing sci-fi. And then so we started this company, but we didn't have. It was called Haptec at this time. It was in '95. But so we want to commercialize the pantograph for graphics, for actually not doing accessibility, but helping people to do CAD, computer-aided design, like parts. And the point was that actually the device was very simple, 2D, but you could feel 3D with it because of that illusion that was so compelling that actually if you had gradients in the force field, then your brain would make it a 3-dimensional shape actually. And so that was the point. And then but the business didn't go so well. Technically it was fascinating, but we made many mistakes, like young people, like doing too many things. It was a technological marvel, but it was not a good. It was not a sustainable product, and so essentially we run out of investor money in 5 years completely, and then we got bought by Immersion. That's how things happen.
Today you would say that you made an exit, so it's good.
Yeah.
That's a success. It's not if you run out of money.
And actually, Immersion purchased not the technology, but the people.
The people or the team. Okay, understand.
And then I had 2 other started companies later. who developed well and failed for different reasons. And the second one actually was clearly a lack of a good business acumen, actually. He was in the medical area. It was also a great technical idea, very wonderful, but the implementation was not good. And as you know, in industry, the ideas are not so important. It's really the implementation that matters.
Yeah, execution beats everything.
Execution, yeah. And
Absolutely.
so that's my advice, really.
Execute faster. No,
Fast, yeah, cut the ambition.
Yeah.
Keep things manageable.
Absolutely. So thanks, Vincent. Thanks, Vincent. This closes our first part. And we move now in the area of expertise, which is we will talk a little bit more about your, we want to focus on your lifelong learning here. This is what we're really looking for. You are a really long career and you have this a view of what's happening to the field. And I think this is what we want to aim here. So you talk about immersion. So we had Chris Ulrich, the current CTO of immersion at the club 2 weeks ago. And he mentioned how haptics changed in the last 20 years from being focused to kinesthetic or force feedback devices to fully focused on vibrotactile in the latest year, right? What are the trends that you saw coming and going in haptics technology in the last 30 years?
Yeah, actually, from at the beginning, the big thing was space exploration. That was it was actually what actually before this accessibility project I was talking about. Actually, I had a contract with Canadian Space Agency to put haptics on Mars. So that was the idea, to have the Martian robot scratch the surface, and then you could feel actually how the rocks, how they behaved, and so we had a contract to make a hand controller to do that with the. But of course, it never happened. The space business is very slow, but. Along the years, so you had force feedback, and then you had a lot of emphasis on really complicated hardware. And then after that, you had like a big wave. Everybody was working on medical simulation. And then it didn't pan out so well because actually it's not very accepted. But, surgeons, they don't really care actually. About the mechanical fidelity, it is a fact that surgery is mostly visual, and so there are lots of things to discuss around that. But it's true that the medical simulators with haptics have never taken off because there is no real need.
You shouldn't say this to a number of entrepreneurs that are doing that. But
well, no. But you have to accept the fact, that there's been so much research into that and so little result, and then there was a big wave in maybe in the past 10 years to go to simplicity, like surfaces, vibrotactile things that are much simpler to put together and then turn into things that are useful. And that actually probably deeply rooted into a very deep biological reality of what our haptic system does in our cognition of the mechanical world, actually. And that's something I mentioned last time, but if you think about it, most of important and useful or pleasant or interesting mechanical signals are transient. They are very fast and they don't last. The persisting component is very, very little used, actually. It is in some cases when you rest on a wall or you're but otherwise there's really little need for it, and that's the most complicated thing to do mechanically. So So that explains probably a lot.
That's great. It's fantastic answer, and I think you need to be there to understand what's going on in the different waves of interest, or where money grants goes, where things work and doesn't. What is important here is that you also build businesses or out of that. So you also saw the other side of the wall, which is how can we make money out of that? How can bring real value to the world, which is generating products and solving people's problems. So that's pretty amazing. Thanks for the answer. And I think it ties really well to the next question we planned out. It is, I mean, you contributed massively to the understanding of tactile perception, right? So how our understanding of a tactile perception evolved in the latest year compared to how it was at the beginning of your career?
Can you repeat the question? I missed a few words.
So I mentioned that how tactile perception, what was the thinking about tactile perception back when you started, and how it evolved during your career?
Right. Yeah. From the very beginning, there was a lot of emphasis on performance. Like, for example, I remember, like everybody was working on Fitts law, like whether you could move faster, from A to B, and then be more accurate. But and then whether having force feedback or haptics or whatever mechanical feedback, whether that would help you to be more efficient. I remember, we worked a long time on trying to hapticize this. The cells of Excel, so you would click into the that was a big project. But in reality, nobody really cares, whether you can go fast in doing that. I mean, it's really marginal. So there are many other aspects of having an interface that has mechanical qualities than just being able to do it better, faster. And there are lots, like simply more relaxing or less effort, or more pleasant or surprising, fun, Actually, this is really interesting. About tactile illusions, there are lots of them. And when you do visual illusions or you do auditory illusions, you show them to people, they found that intriguing and interesting. But when you show them tactile illusion that work really well, they always find them fun and humoristic, And it's really a good cognitive question. Why is it that when you have tactile illusions, it induces merriment in people? And which is not at all the case in the other type of. Now, if you do a vestibular illusion, people don't like it at all. But the tactile illusions, they are always fun and interesting, and that's probably true of interfaces as well. That there's something about the cognitive aspect of tactile interaction, which is connected to something about pleasantness or pleasure and surprise.
Let's go back to tactile perception. Yeah. During our last conversation, you were mentioning how, I'd say, at the beginning of 1900, there was this idea that tactile was an integrated perception, and then when you started, there was a sort of divisive perception of touch, and right now we are going back to this global integrated approach for whole tactile perception. Can you develop a little bit on that, like last time? I think that was an extremely interesting aspect of your answer.
Yeah, I've been heavily influenced by spending time with neurophysiologists, mostly coming from the general direction of Sweden, and some of my colleagues, they have a very long perspective on the study of somatosensation, if you want, over the past century and a half. And what I got from them is actually it's like in industry, but in research the movements are much slower. But the early physiologists like Sherrington, they would think of somatosensation as an integrated function that was not assigned to particular organs or even particular neural structures or any. It was something that animals had to do, or to know where they are in space and where things are, and so if you read the old books from Sherrington and of that time, that was really the whole idea that functions are not mapped onto organs or places in the brain actually, and then in the mid 20th century, there was like a movement trying to rationalize, how sensors work, and then now we actually experience that a lot. There is not a single engineering paper in haptics that starts with the fact that we have 4 kinds of mechanoreceptors. And it's really amazing, because if you remove that sentence, the paper would be just perfectly okay, and there's absolutely no consequence. And it's really strange actually to have. It's like saying, oh, okay, you do a paper in computer graphics, and then you have to talk about cones and rods. Yes, of course. It is a very strange thing, actually.
Actually, my thesis, I had to put that stuff in, so I fully relate with that.
And then so this is the result of this effort in trying to give functions to little things, like but the physiological reality is that it's not so simple actually. And so there's not really need to talk about it if you don't have anything special to say about and on top of it, that actually the neurophysiological data with modern methods is changing a lot. So and then so that's what I would say that and maybe the other influence come from robotics, because when you build robots, you have to put sensors and you have to have control algorithms, and then you are forced to give functions to organs. But in an animal, I don't think that's really a good model at all. It's like it's what I called in sort of like technocentric interpretation. Like actually, there's a very good story about this. In the 50s, the best model for the brain was the telephone switchboard. And actually, when you think about it, it's really a good model, because basically that's what it is. Like a lot of wires, and they switch, and then after that, the best model was the computer. And then now you have other models which are very much techno motivated, and so that's the other part of the story, is like we feel as humans to project our it's like technomorphic ideas on things that we see living, but yeah, it's really a bias actually.
Let's build on this technomorphic approach. And so if I try to reinterpret what you're sharing about touch, we could say that our human touch perception is a pattern recognitor, which has no direct influence to the specific sensor, but it recognizes a certain kind of behavior of the response and categorizes that during our learning process. When we were born and we learn how to categorize things and give them a name or associate them with that experience, and that pattern is that experience, disregarding of what is going on in our basically fingertip, whatever. Makes sense, this kind of interpretation?
Yeah, yeah. Actually, when maybe you've done a bit of teaching in haptics, but one of the things you can show to the students is really amazing. Actually, it goes back to Susan Lederman. You take a piece of rubber here, and then you feel it. It feels rubber, and then you take a stick. Okay, you take a stick, and then you explore, and then you have very much the same sensation. It's really astonishing, actually, because the peripheral input is completely different in the two cases. But the sensation is not so different. I mean, it's different, but not tremendously different. And so how do you explain that? It's really actually the somatosensation is a lot more powerful at knowing objects than actually vision is, or even audition, actually. I did a bit of psychoacoustics in the past also. Yeah, I realized that actually. So that's something probably, I don't know, you could explain it. I'm not the only one to say that, but the sense of touch has evolved in humans or primates or many animals for the purpose of locomotion and purpose of manipulation, and so that's maybe the start of the story, actually. It was not evolved to read Braille or you know.
I mean, it's good that we are repurposing it. That's great
But you
for
can
accessibility.
repurpose, of course, yeah.
We can repurpose it. I mean, there was we had a nice chat about that with David Eagleman. That was at the club like not long ago about repurposing touch for many different topics. And I invite the podcast listener to go to hear episode 10. It's wonderful, and David is great in that direction. So Vincent, let's move to the next question here. So what are some interesting projects that you are working on right now? Can you share us something?
Okay, well, as I mentioned, I'm still working with graduate students, and then so I'll start in alphabetical order. There's Aruna at Actronica. She's doing really interesting work in machine learning technique applied to create content. So this is really moving fast and well. So that's a fascinating project. It has a fairly solid scientific basis to it. Actually, it's rooted in the question of what the natural statistics of the mechanical world. What is in common between different classes of objects, different categories of objects. So that's one project. Another one, we're also revisiting the tactile display problem with Jerke Bulan. It's never been really solved, and then so we're trying to extend the temporal and spatial resolution question using different type of techniques. And by the way, actually, Jerke Bulan just came across a really kind of very cool new tactile illusions that doesn't fall in any of the categories that I knew of. So that's interesting. And then I also work with Karina, a driller at Delft, on sort of more behavioral questions, like the question of metamers. What are the combination of different physics that give you similar sensations, because these are really important in general. And then otherwise, I have personal projects which I work on my own, which I won't tell you.
Are they
This is the
also
secret
related
we want.
are they related to haptics, or is this like a complete outlier? Are you building cars or something?
No, 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 no.
Just a little hint.
No,
It's the next.
I'm working on my own on finger mechanics.
And let's discuss. Can you share something more about this new tactile illusion? If is it already published, or is something that you are
No,
yet to
it's not
publish?
published. But well, what it does, I tell you, you touch a surface and you feel the surface sliding on your finger.
Ah, that's cool.
It's really good. Yeah, and it's very robust, and it just tricks. So
I should pass by to test it.
yeah,
Next
yeah,
time,
you should.
I come to the office.
Yeah.
So thanks, Vincent. This closes our area of expertise section. I will leave the mic to Ashley for our future of haptics.
Awesome. All right, Vincent. This is an area I think a lot of people want to hear your thoughts on, because you have such an amazing background, history in the space. One of the questions we get is, a lot of people think that we've leveraged the most we can out of vibrotactile. Can you give us an idea? Maybe you don't agree with that, but what would be next from vibrotactile?
What else?
That is the question.
Well, the way I think of it is really you have categories of tactile inputs, and actually roughly they fall into, if you want, quasi-static sort of things that don't change fast, and then things that are dynamic. And I think they are rooted into, actually that's why I work on the mechanics of fingers. I think they are rooted into the dynamics of our extremities. So it's not an arbitrary distinction. It is actually a physical distinction. It has to do with wavelengths and stuff like that. So it's very fundamental, and that gives me ideas about new approaches for doing displays that are simpler and more efficient. But vibrotactile is a very vast domain. It's there's been some effort in trying to do electrostimulation. It's interesting, but of course it's lacking a lot of the practical convenience. It actually could be, it really can easily slip in the domain of pain.
It's great for paper. It's not great for products.
Yeah.
People tend to respond
yeah,
bad.
exactly. But it has definitely a huge importance in clinical applications because of the accuracy and the repeatability. But in industrial practice, it's hard to think of it actually. But vibrotactile, there's the hand, but there's all kind of other regions of the body that are interesting, of course. In the past, we worked with the feet. It's wonderful, actually, because the feet are almost as capable as hands, and they are producing huge importance in cognition of our space around us. So, so feet is a really good place, actually. And it's not evolving like computer, like graphics. In graphics, there was all kind of different screens technologies for different purposes, and then they got pruned, and then now you have only a few left, and they are really amazingly capable. Things that are were more invasive, like at some time in graphics, there was a big effort in trying to paint images with lasers on the retina directly, and it really works well, but when you think of it, it's lacking this practicality.
Magic Leap raised how much $3 billion to make it into the head-up display, right? So they failed.
Yeah, exactly. So haptics is a little bit like this, but there will definitely be inventions in simple either increasing quality, simplifying the device, which is probably the most important thing, and that goes through thorough study of the peripheral inputs actually. But there's a lot of room for improvement. Actually, your kid just proved it actually.
Amazing. That's exciting. I like that you brought up some areas that a lot of people don't think about would be interesting for haptics, feet definitely being one of them. So that's a very interesting space. In terms of the vision or where you see haptics evolving, what are you seeing in like the next 5 to 10 years?
You can think into body parts or like wearables. So that's really something that is bound to happen. At the company, we introduced this vest, which it really works well, and it's affordable. Affordable in an industrial sense. There is no tremendously complicated manufacturing problems about it, but it's very effective. And then you could think that there will be more of that, in wearables, objects that already exist and become hapticized. That's actually one way to think of it. Like not inventing new devices, but things that are already existing and being given haptic capabilities actually.
It's funny because when I read all the old academic papers, it's like I'm seeing everything that we have now kind of coming to fruition. A lot of people were doing a lot of really interesting research in like shoes for locomotion and like direction, vests, suits, headsets, controllers. Like it's been around for some time. People have just been kind of like coming with ideas. What do you think the kind of like maybe next technology might be that has kind of existed in academia but maybe hasn't come to life yet? Is there anything that kind of stands out to you?
Yeah, well, as you know, I have many colleagues working on surface, either by, and so that's a very something that I hope will become, industrially.
That's hard.
Viable, but there are quite a few problems to be solved before that happens, probably. Beyond just the power consumption but the sheer quality is too low. Yeah.
I remember Chris mentioning 2 weeks ago exactly the same thing. He was extremely bullish on surface haptics. Chris from Immersion. They invested some time, but today I speak also from a direct experience. There was no direct implementation into the market, at least at a meaningful scale, for usually problems of integration. It's quite hard integrating surface haptics. So maybe it will happen. We don't know. But
but it's not easy. It's not easy, but can be done. Yeah.
No, it can be done, absolutely. I mean, it's more of a product integration problem right now. It's not anymore a technological demonstration problem. So it's really about the cost, repeatability, and affordability, basically. But yeah, maybe they will come there. We'll see.
Yeah. So to answer, probably what's going to happen in the next 10 years, now when you buy a graphics display, basically you have OLED, or you have only a few possibilities. and then no LCD, and but in haptics you will have a whole diversity. That's the only way. Actually, it's the way the world is made. Actually, actually, if you do natural statistics, you realize that actually the visual world is really boring compared to the haptics world, which is much more varied and dynamic. And the vision scientists actually admit it. It's basically the visual world is quasi-static. Nothing moves, and when things move fast, then you don't see them.
That's an easy way to solve the problem.
Yeah. But the mechanical world is incredibly more varied and has many more dimensions, many more viability, and so that will be reflected in the devices and the algorithms.
Just to make things even more complicated than what they are. More fun.
Awesome. So that wraps up our kind of questions on the future. I think we can kind of jump into some of we touched on a lot of different areas. So we can probably jump into some of the questions that we have from some folks from the audience that shared them. And then I'm sure Eric and I have just, we've been taking notes along the way of some of the things you said, Vincent, which is super interesting. Eric, you want to kick us off?
Yeah, sure. So just for our listener, we will close here the recorded part. So thanks a lot for being here with us with Vincent. And following the Haptics Club, you can find us on Twitter, LinkedIn, and we have a website right now. You will be able to buy t-shirts soon. So mark down the address, thehapticsclub.com. That's important. And guys, see you for the next event. We have Happily Robotics. We have a researcher from them that they are building a fantastic force feedback platform for surgery training. So we will discuss with them about the potential market acceptance of this platform. So it will be a really good evolution from the feedback from Vincent. And see you next time.